To summarize the experimental facts observed for the E2 elimination. The conditions are similar to those used in the SN2 reaction, however the pathway takes a different turn, resulting in alkene products. This is due to the alpha carbon being crowded and the SN2 not being viable since the nucleophile is blocked from attack at C. This reaction is typically irreversible, with the alkenes being formed completely and not reverting to starting materials. This suggests a process driven by relative transition state energies and not relative product stabilities. The fact that adding more base or more alkyl halide makes the reaction go faster means that the slow, rate-determining step is bimolecular. Evidence so far suggests that this reaction is a concerted, bimolecular process that is irreversible. So now we examine the product side of the equation. The more substituted alkene is favored when a small base is used. This is explained by the lower energy of the transition state that leads to the Zaitsev outcome and not the relative stability of the alkene product. The extra electron donating alkyl groups help to stabilize that process versus others. Likewise for cis and trans isomerism, where the trans isomer is usually favored due to a more favorable transition state with fewer steric interactions. The basic experimental evidence leads us to conclude that this reaction is irreversible, which makes sense since electron-rich alkene products are unlikely to be attacked by the electron-rich leaving group. Secondly, the kinetic experiments, where addition of base or alkyl halide lead to faster reactions, means the rate-determining step is bimolecular. This is backed up by a strong kinetic isotope effect, in which replacement of the beta-H with deuterium results in a slower reaction. This is because a CD bond is stronger and therefore harder to break than a CH bond. The formation of the more substituted alkene when a small base is used is further evidence of a concerted process in which transition state energies govern the outcome. We now have enough evidence to write a convincing mechanism for this process that agrees with all the data collected. We must keep in mind that only three things need to happen in this reaction, namely removal of the beta proton by the base, formation of the pi bond, and loss of the leaving group. Either a stepwise or a single-step concerted process could be invoked here. If the reaction were to be stepwise, the leaving group could break off first to generate an intermediate, however this would be a unimolecular rate-determining step, which does not agree with the evidence. The concerted one-step process fits all of the data collected. Here, all events may occur at once in a bimolecular step in what is now accepted as the E2 elimination. We now need to come up with the mechanism arrows needed to describe this elimination process. Since only three events are occurring, we only need three curved arrows. One describes the base forming a bond with the beta proton. The second shows the C to H bond breaking, with that pair of electrons being used to form the pi bond. The third arrow describes how the leaving group breaks away and takes with it an extra pair of electrons that were introduced by the base. Use of each of these three arrows describes, succinctly, the bonds forming and breaking. The arrow direction is flowing from electron-rich to electron-poor areas, with the octet rule never being broken and the negative charge ending up at the best possible place, the halide. To summarize, the E2 pathway takes over on crowded substrates when the SN2 mode of reactivity is blocked by substituents at the alpha carbon. Kinetic studies show the reaction to have a bimolecular rate-determining step, and the reaction is likely to be irreversible. Both regiochemical and stereochemical outcomes depend on transition state energies. Additionally, switching to a larger base will result in a preference for a less substituted Hofmann alkene, since the transition states will also be affected by where the larger base can get to. A more accessible proton will be removed faster. Overall, the evidence collected leads to the concerted pathway for elimination known as E2.